June 30th, 1908. In the remote reaches of central Siberia, the morning sun had only just begun to crest over the horizon of the Podkamenia Tunguska River. It was a region of endless larch forests, marshes, and isolation, a landscape that, for centuries, had been shaped by the slow, rhythmic cycles of nature. But at approximately 7:17 a.m., that rhythm was shattered. Witnesses hundreds of kilometers away described a column of blue light, nearly as bright as the sun, moving vertically across the sky. Then a series of sounds followed. Some described them as heavy artillery fire, others as the crashing of giant stones. In the trading post of Vanavara, some 65 kilometers from the epicenter, a man named S. Semenov was sitting on his porch. He later recounted how the sky seemed to split in two, and a heat so intense radiated from the horizon that he felt as if his shirt were catching fire. A moment later, a shockwave threw him from his steps, leaving him unconscious. When he woke, the air was filled with a roar that shook the very foundations of his home. Windows shattered. A hot wind swept through the valley, toppling fences and bruising the earth. To Semenov, it must have felt like the end of the world. But for the rest of the globe, the event remained a ghost, a tremor on the, quote, edge of perception that would take decades to fully acknowledge. Thousands of miles away, in the United Kingdom, sensitive barographs at meteorological stations began to twitch. They recorded a pulse in the atmosphere, a pressure wave that had traveled across the continent. In the days that followed, an eerie phenomenon took hold of the night sky across Europe and Western Asia. The darkness simply never arrived. In London, citizens reported being able to read the fine print of a newspaper in the middle of the night without the aid of a lamp. In Stockholm, photographers were able to take landscape portraits at midnight using only the natural light of the sky. The heavens were filled with glowing, silvery clouds and a persistent, golden-red hue that shimmered along the horizon. Scientists at the time were baffled. Some suggested it was icy dust from a high-altitude meteor, while others wondered if it was a peculiar volcanic eruption. But there was no smoke, no ash, and no clear origin point. Despite the global atmospheric anomaly, the epicenter of the event remained silent. In the early 20th century, the Siberian taiga was a formidable barrier. It was a place of impenetrable swamps, sub-zero winters, and a lack of any infrastructure. The Russian Empire, already simmering with political unrest and teetering on the edge of revolution, had little interest in investigating a tremor in a wasteland where, by all accounts, no one of consequence lived. But as the years passed, the stories from the local Evenki people began to trickle out. They spoke of a fire god named Ogdi, who had descended upon the forest, cursing the land and striking down the trees with an invisible fist. They spoke of a place where the forest had simply ceased to be. Yet, for nearly 2 decades, these accounts remained the stuff of folklore, unexamined by the scientific community. It wasn't until 1921 that the silence was finally broken. Leonid Kulik, a Russian mineralogist with a fascination for meteorites, began to piece together the scattered reports. He was convinced that a massive iron meteorite, a treasure trove of extraterrestrial metal, had struck the Siberian wilderness. To Kulik, this wasn't just a scientific curiosity. It was a matter of national importance. But his first attempt to reach the site was thwarted by the sheer brutality of the landscape. It would take another 6 years of lobbying the Soviet Academy of Sciences before he could return, with the resources needed for a full expedition. In 1927, Kulik finally pushed deep into the heart of the Tunguska region, expecting to find a scarred landscape dominated by a massive, gaping crater. What he found instead would haunt the rest of his career. As Kulik and his team struggled through the dense undergrowth, they noticed something unsettling. The forest was changing. The trees weren't just dying, they were physically transformed. At a certain point, the team emerged from the, quote, thicket into a vast graveyard of timber. For miles in every direction, tens of millions of trees lay flat on the ground, their trunks stripped of branches and bark, all pointing away from a central point like the needles of a compass. The scale was staggering. Later estimates would suggest that 80 million trees had been leveled across 2,000 square kilometers. It looked as though a giant hand had reached down and smoothed the earth. Kulik pressed forward, his heart racing. He was certain that at the center of this radial pattern, the great impact crater would be waiting. He imagined a hole in the earth, hundreds of meters wide, filled with the remains of a celestial visitor. But as they reached the exact epicenter of the devastation, the narrative shifted. There was no crater. Instead, at the very heart of the blast zone, where the force should have been most destructive, a grove of trees remained standing. They were dead, stripped of their limbs, and scorched by heat, standing like haunting silver telegraph poles in the middle of a wasteland. There was no deep indentation in the soil, no jagged rim of displaced rock. The ground was swampy, unremarkable, and frustratingly intact. Kulik was confused. If a meteorite had struck the earth with enough force to level a forest the size of a major city, physics dictated there had to be a hole. He began to search the nearby peat bogs, hoping that perhaps the impactor had shattered into smaller pieces, burying itself in the soft, marshy ground. He spent months excavating potholes, believing them to be small impact sites, only to find that they were natural thermokarst formations, the result of melting permafrost. The deeper he looked, the less sense the scene made. Records suggest that Kulik became obsessed. Returning to the site multiple times over the next decade, he was looking for a physical object, a piece of iron or stone that he could hold in his hand. But the taiga refused to give up its secrets. The evidence was everywhere, yet the culprit was nowhere to be found. As news of Kulik's failure to find a crater reached the outside world, the scientific community began to reconsider the nature of the event. If there was no impact, then what could have caused a blast estimated to be 1,000 times more powerful than the bomb that would later be dropped on Hiroshima? Some researchers began to look closer at the trees themselves. The butterfly pattern of the fallen timber suggested a very specific type of energy release. It wasn't a ground-level explosion. The way the trees at the center remained, standing while those further away were flattened, suggested the force had come from directly above. This led to the first major shift in the investigation, the theory of an major atmospheric airburst. But even this explanation carried its own set of problems. If an object had exploded in the midair, what was it made of? Why was there no debris? And most importantly, what kind of celestial body could vanish so completely, leaving behind nothing but scorched earth and a century of questions? What they found next changed the narrative entirely. The realization that the blast had occurred miles above the ground changed the scope of the investigation. If the object had never touched the Earth, the search for a crater was a fool's errand. But this revelation only invited more disturbing questions. For an object to disintegrate with such violence without leaving behind significant fragments, it had to be moving at a speed and composed of a material that defied easy categorization. In the late 1930s, Leonid Kulik's work was cut short by the tremors of a Klein-dot different kind, the gathering clouds of World War II. Kulik, a man who had dedicated his life to the mystery of the taiga, joined the People's Militia to defend Moscow. He died in a German prisoner of war camp in 1942. His dream of finding a piece of the Tunguska messenger unfulfilled. With his death, the site was reclaimed by the forest. The Siberian wilderness, it seemed, was content to bury the event under layers of moss and new growth. However, the silence didn't last. The end of the war brought a new era of the silence physics, one dominated by the terrifying power of the atom. When the world witnessed the airburst explosions over Hiroshima and Nagasaki, scientists couldn't help but notice the chilling similarities to the Tunguska site. The telegraph pole trees at the epicenter of the Siberian blast were a near-perfect match for the charred, standing ruins at the center of the nuclear strikes in Yorpan. This sparked a new wave of interest. In the late 1950s and early 60s, a new generation of Soviet scientists, equipped with more sophisticated tools and a better understanding of shockwave physics, returned to the Podkamennaya Tunguska. Led by researchers like Gennady Plekhanov and Nikolai Vasilyev, these expeditions moved away from the search for a large crater and began looking for something much smaller. They began to filter the soil and the peat bogs, looking for microscopic remnants. They were searching for extraterrestrial dust, tiny, glass-like beads known as spherules. These microscopic spheres are formed when a meteorite is vaporized by the intense heat of atmospheric entry and then cools rapidly. What they found was subtle but undeniable. Deep within the layers of the peat, corresponding exactly to the year 1908, they discovered a high concentration of silicate and magnetite spherules. Some of these tiny beads contained high levels of nickel and iridium elements rarely found in the Earth's crust but common in space-borne rocks. This was the first smoking gun that a celestial body had indeed been present. Yet, even this evidence was paradoxical. The total amount of material recovered was minuscule compared to the estimated size of the object, which researchers calculated must have been between 50 and 100 meters wide. If a rock that large had vaporized, where was the rest of it? Some historians believe that the answer lies in the composition of the object itself. This is where the comet theory began to gain traction. Unlike asteroids, which are primarily rock or metal, comets are dirty, snowballs, mixtures of ice, frozen gases, and dust. A comet entering the frozen atmosphere at tens of thousands of miles per hour would experience immense thermal stress. As the ice turned instantly to gas, the internal pressure would cause the object to detonate like a massive steam boiler. This would explain the lack of debris. The ice would have simply evaporated, leaving behind nothing but a cloud of water vapor and a dusting of microscopic minerals. But there is no clear consensus on this. Asteroid proponents argue that a comet, being much more fragile, would have exploded much higher in the Seventh atmosphere, likely failing to produce the devastating ground-level shockwave that flattened 80 million trees. While the scientists debated the physics, Another mystery was unfolding in the geophysics biology of the region. As researchers mapped the blast zone, they noticed something peculiar about the trees that had survived the perimeter of the explosion. In the decades following 1908, the forest hadn't just recovered, it had accelerated. The growth, rings of the larch, and pine trees showed a dramatic increase in speed. They were growing significantly faster than trees in neighboring, unaffected areas. Initially, some speculated about radiation, fueled by the comparisons to Hiroshima. However, extensive testing of the soil and the tree rings found no evidence of abnormal radioactive isotopes. The accelerated growth remains a point of contention. Some believe it was simply the result of the fire and the blast clearing out the old, dense forest, providing the survivors with more sunlight and nutrient-rich ash. Others suggest more complex chemical changes encased the soil, perhaps deposited by the exploding object itself. But as the team moved further into the butterfly of the fallen trees, they realized the shape of the destruction was even more precise than they had imagined. By meticulously recording the orientation of every fallen trunk across hundreds of kilometers, researchers were able to create a mathematical map of the blast. The shape resembled a giant butterfly with a wingspan of 70 kilometers. This specific geometry didn't just point to an explosion, it pointed to a trajectory. The object hadn't just dropped from the sky, it had arrived at a shallow angle, likely between 30 and 35 degrees. This meant that the object had traveled through a vast swath of the atmosphere before it finally gave way. Eyewitness reports from 1908 began to take on new weight. People hundreds of miles to the south had reported seeing the light moving from the southeast to the northwest. Others, further east, claimed a flashed ATG's different path. This discrepancy in witness accounts led to a controversial suggestion that the Dishan 7000 object may have changed direction in midair. In a strictly scientific context, this is almost impossible for a natural celestial body. It fueled decades of fringe theories about intelligently controlled craft, but mainstream investigators looked for a more grounded explanation. They wondered if the object had fragmented in stages, creating a series of secondary shock waves that confused observers on the ground. And yet, there was one more piece of physical evidence that refused to fit the mold. In the 1990s, an Italian team from the University of Bologna, led by Giuseppe Longo, turned their attention to a small, deep lake about 8 kilometers north-northwest of the epicenter. It's called Lake Checo. Unlike the other shallow, swampy lakes in the region, Lake Checo is funnel-shaped and unusually deep. Using sonar and seismic reflection imaging, the Italian team discovered something buried beneath the lake's floor. There is a reflector, a pocket of dense material about 10 meters below the sediment. They propose that Lake Checo isn't a natural lake at all, but the elusive impact crater that Kulik had spent his life searching for. They argued that a fragment of the original object had survived the airburst and struck the Earth at a lower velocity, carving out the deep, conical hole. But the Lake Checo theory immediately met a wall of skepticism. Core samples from the bottom of the lake seemed to suggest that the sediment was much older than 1908. Trees on the shore of the lake appeared to be older than the event itself, and they showed no signs of the physical trauma one would expect from a localized impact. If the lake were a crater. Those trees shouldn't to be there. What happened next remains unclear, as the scientific community is split. Some view the lake as the final piece of the puzzle, while others see it as a coincidental natural feature of the Siberian karst landscape. The search for a physical piece of the Tunguska object, a macro fragment, continues to this day, with every new expedition hoping to find the fragment that finally ends the debate. But as researchers push deeper into the 21st century, they realize they might have been looking at the wrong kind of evidence. They began to look at the atmosphere of 1908, not just as a medium for a shockwave, but as a chemical recorder. And that's when things began to shift. In the late 2000s, researchers turned their gaze away from the soil of Siberia and toward the ice of the ends of the Earth. By analyzing ice cores from Greenland and Antarctica, they were searching for a chemical signature of the 1908 event. If a massive object had vaporized in the atmosphere, the resulting dust and gases would have circulated globally, eventually settling and becoming trapped in the polar ice. Records suggest that they found exactly what they were looking for: high-resolution analysis of the ice layers corresponding to 1908 revealed a distinct spike in iridium and platinum elements that act as a celestial fingerprint. This didn't just confirm the extraterrestrial origin of the blast. It allowed scientists to calculate the sheer scale of the energy released. But even with this global confirmation, the central paradox remained: how could something so massive leave so little of itself behind? The answer began to take shape not in a laboratory, but in the sky over another Russian city. In February 2013, a streak of light blazed across the sky above Chelyabinsk. For the first time in history, a significant meteoric airburst was captured by thousands of dashboard cameras and security sensors. The Chelyabinsk meteor was roughly 20 meters wide, far smaller than the Tunguska object. Yet its explosion shattered windows for miles and injured over 1,000 people. When scientists analyzed the data from Chelyabinsk, they found a modern blueprint for what happened in 1908. The shock wave, the thermal radiation, and the way the object disintegrated under atmospheric pressure all mirrored the Tunguska reports. Most importantly, it showed that a rocky asteroid, not just icy comet, could explode with incredible violence in the upper atmosphere, leaving behind only tiny fragments scattered across a vast area. This modern parallel gave researchers the data they needed to run advanced supercomputer simulations of the Tunguska event. These models suggested that the object was likely a stony asteroid about 50 to 80 meters in diameter, entering the atmosphere at a staggering 54,000 kilometers per hour. At a height of about 5 to 10 kilometers, the pressure of the air in front of it became so great that it acted like a solid wall. The asteroid didn't just break, it detonated with the force of 10 to 15 megatons of TNT. The simulation perfectly recreated the butterfly-shaped pattern of the fallen trees and the standing telegraph poles at the center. It explained why there was no crater. The main body of the asteroid was pulverized into dust before it ever touched the ground. Yet, even with the physics largely solved, the human element of the story remains draped in a certain melancholy. We are left with the accounts of the Evenki people who returned to the site years later to find a landscape that felt fundamentally altered. Some described a new forest that felt different to the touch, and others avoided the area for generations, believing the veil between worlds had been thinned. There is no clear consensus on the final fate of every fragment. Some modern researchers still hold out hope for Lake Checo, while others believe the pieces are so deeply buried in the Siberian permafrost that they may never be recovered. The site is now a protected nature reserve, a quiet, haunting monument to the day the sky fell. What remains most unsettling is the realization of how close the world came to a different history. If the Tunguska object had entered the atmosphere just 4 hours and 47 minutes later, the rotation of the Earth would have placed the city of St. Petersburg directly under the blast. A major cultural and political capital would have been erased in an instant, long before the age of nuclear weapons. Today, the trees have grown back. The scars on the landscape are visible only from the air, where the faint outline of the radial fallen forest can still be traced by those who know where to look. The mystery of Tunguska has transitioned from a frantic search for a crater to a profound lesson in planetary vulnerability. We live in a shooting gallery of cosmic proportions, and for all our technological advancement, we are still learning to read the signs left behind by the ghosts of 1908. The silence of the taiga is a reminder that the universe does not always leave a footprint. Sometimes it only leaves a shadow. And as we look to the stars today, scanning for the next visitor, we are forced to acknowledge that the most significant events in our history are sometimes the ones that leave the least behind. The 80 million trees have returned to the earth. The blue light has faded from memory, and the Tunguska River flows as it always has, carrying the secrets of a morning where the world changed. And yet, in the eyes of the earth, nothing happened at all.